the 3rd Brigade, then our nation's operational deployment force, pushed hard for the modernisation of that formation. He premised the requirement, quite accurately, on the statement that when he assumed command of the brigade, the only digital technology available was the clock in the dashboard of his staff car. A few years later, the story is told of that same senior officer, now a general, bursting into an office in Victoria Barracks in Sydney, brandishing a newspaper with a full-page advertisement for computers. He enthusiastically slammed the newspaper down on the desk in front of a startled staff officer, declaring that, while he wasn't quite sure what those computers did, he wanted lots of them. This is a true story. The Australian Army has long had a fascination with science and technology. Like all armed forces, we are on a perennial quest for the promise of that new cutting-edge capability that will deliver, no matter how fleetingly, an asymmetric advantage over a potential adversary. The Army is a force that both soldiers the equipment and equips the soldier. This is why we always need to think deeply about how we enable our people with the right science and technology, using the right ways. We have come a long way in a few short decades since the digital clock in the commander's staff car. Most of this development has been deliberate and designed, but I think we should never miss the opportunity to be dragged forward by enthusiastic modernisers, who may not always fully comprehend or appreciate the innovations on offer, but have the vision and risk tolerance to pursue them. We have plenty of opportunity to advance our levels of technological capability and sophistication. In the first of the new Australian Land Warfare Concept series, in a paper titled Coming to Terms with a Modern Way of War, Precision Missiles and the Land Component of Australia's Joint Force, authors Colonel Chris Smith and Dr. Al Palazzo write, thanks to a significant and sustained investment over many years, Australia will soon boast a 5th generation Air Force. While there is no similar generational construct for the Land Force, if there was, Australia's Army, by comparison, is probably 4th generation at best in relative terms. The Army's story of capability development has been one of slow and steady evolution rather than innovative revolution. That's okay, but I believe that we have the ability and need to get better at design and development. Having our Army within the same technological generation as the rest of the force is a reasonable aspiration in this era of digital connectivity. And I think it's a necessity if we're to realise the true combat value of joint operations. My sense is that perhaps the Army, of the 3 services in Australia's Joint Force, may have a slight advantage with regard to innovation and risk. Let me explain. Australia's 2016 Defence White Paper, the Defence Integrated Investment Program and the Defence Industry Policy Statement set out a long-term capability acquisition program. Just under 20% of the dollar value of planned acquisitions could be classified broadly as joint land capabilities. Now, please don't get me wrong, I am not advocating for change here. I am appreciative of what we have and what we're getting. And any money spent on our sister services that enhances the wider joint force effect is a great thing. Ultimately, it helps keep our soldiers and our nation safe. The point which I seek to make is that both the net cost of the capabilities and platforms Army needs and the net amount in the Integrated Investment Program are nowhere near the scale of non-Army acquisitions. And while I'm hesitant to refer to them as cheap, the relative amount spent on iconic land projects compared to projects such as the Joint Strike Fighter or future submarines means there is also relatively less national risk and potentially the ability for more innovative approaches. Arguably, Army money is more disaggregated, malleable, and some of it can bear a larger number of smaller tranches of risk opportunity. Spiral risk development, if you will. Of course, as Major General Fergus McLaughlin, the head of Army's modernisation and strategic plans, keeps reminding me, the downside of our smaller dollar value projects are smaller science and technology budgets within these projects. So, we need to think clearly and creatively about how we maximise the return on our and others' science and technology investment. One way to maximise this investment is to seek to learn and benefit from crossover or bleed from other larger ADF high-tech projects. Sharing insights across the Joint Force and looking for knowledge transfer where possible and appropriate is something my colleagues, both Dr. Zielinski and Mr. Gillis from DSTG and CASG respectively, and I are very keen to see occur. More capability for each research dollar. In the case of the air domain, for example, it is immediately obvious that platform integration with the advent of the Joint Strike Fighter, Wedgetail and Growler will have benefit for the integration of Army platforms in projects such as Land 200. In the maritime domain, research into submarine and surface vessel stealth may generate technological innovation with utility for land vehicle systems. In short, we remain open to new, collaborative and collegiate ways of thinking about our respective science and technology programs. Being open to new ways of thinking leads to questioning how we might better benefit from our creativity and innovation. I think we can see at least three likely industry innovation strategies available. The first is obvious and may be described as lead globally and win. This is appropriate where you have both the idea and the ability to develop and competitively market it yourself. An indicative example of this is the great Australian success story of the NOLCA active missile decoy system for naval ships, now being built and sold through an Australian-American collaboration. Which leads to my second strategy, which can be characterised as beginning the collaboration process earlier to lock in our equity. Australian scientists are periodically at the leading edge of scientific breakthroughs that are the best in the world or equal to them. Our value proposition may be to leverage the quality of our people and ideas to form collaborative partnerships early. As the Vice-Chancellor of the ANU and Nobel Laureate Professor Brian Schmidt would say, we need to recognise and seize the fleeting moments of technological leadership we have and lock in our equity when the applied technology is still only a possibility. If we don't, sometimes within 2 or 3 years, our larger global partners, who often have 50 people working on a problem for every one of ours, may well catch up or indeed overtake us. In these cases, the quantity of research dollars and researchers does have a quality all its own. Appreciating the challenges of both these two strategies can lead to small to medium enterprise scale nations, such as Australia, choosing in some instances to adopt a strategy of focusing on component manufacture, assembly and sustainment. This is most applicable where a clear lead in an area has been established overseas, such as the United States in the manufacture of 5th generation aircraft. And a suitable example of this is the work being done by various Australian aerospace manufacturers in producing components as part of the global manufacturing supply chain for the Joint Strike Fighter. All three strategies are viable for Australian defence industry. The art is in managing the risks, something we Australians have often been poor at doing. Perhaps the second one, innovate then collaborate early to lock in equity, hits the sweet spot. It potentially de-risks the development of market phase, the development to market phase, through sharing and engagement, retains the benefits of some IP ownership and allows the chance to continue to learn and to shape outcomes through the process. Or, if we take a Silicon Valley approach, perhaps the second strategy is just a training ground for global domination with the next innovation, an approach which has worked with the Scandinavians. The often overwhelming scope and scale brought to our brought by our partners is amply demonstrated by the United States and their third offset strategy. First announced in November 2014, the strategy has been allocated US $18 billion in its budget. Australia, with a small defence budget by comparison, cannot compete across the breadth and depth of such an endeavour. But it is clearly important from a sovereignty, national science and technology and alliance perspective that Australia contributes where we can. After all, our scientists are up with, if not the world leaders, in areas such as autonomous systems, cyber, quantum computing, hypersonic research, to name a few. I think there's an opportunity for Australian ideas and collaboration in these areas to potentially unlock access to other technological developments where we are not or cannot be significant players because of scale or cost. There are, of course, alternate views as to the third offset strategy. Andrew Davies from the Australian Strategic Policy Institute recently wrote, "Waiting for a once-in-a-generation capability breakthrough isn't likely to be a winning strategy. Agility, the rapid exploitation of new technologies, and the clever application of low-cost systems that can be built in large numbers, R2-D2s rather than Death Stars, looks like a better bet." As a service chief with a relatively modest science and technology budget and an inversely sized appetite for the right, clever but affordable technology, I am intuitively attracted to an approach like the one Andrew is advocating. And after all, as we know, throughout the Star Wars universe, R2-D2s have proven to be far more resilient and long-lasting than any Death Star built by the Empire. I think that the points Andrew makes about seeking agile, quick and clever but low-cost approaches aligns with the direction that Army is taking. These are certainly hallmarks of the inaugural Defence Land Science and Technology Agreement, which was jointly signed by Major General Ferguson McLaughlin and Dr. Peter Shoebridge last week, titled Shaping Defence Science and Technology in the Land Domain 2016-2036. It is a companion document to the Army Modernisation Plan and articulates the science and technology capabilities required to deliver our modernisation lines of effort. A theme throughout is that Army seeks to obtain the most robust, rigorous and independent responses to its research and development requirements. An examination of our research into human performance provides a practical examination of this in application. The Army has identified the performance of its people as a critical factor in building and sustaining a capability edge able to adapt and prevail in future operational circumstances. The associated priorities for research and development are set out in our Human Performance Modernisation line of effort. DSTG's Land Human Systems capability is Army's lead partner for addressing these priorities. But given the breadth and scope of our human performance requirements, no single organisation has the capacity, skills and resources to address each of the requirements by themselves. So together, we must partner with a range of agencies, internal and external, to defence, to collect and develop the necessary information underpinning decisions about next steps in human performance modernisation. In conjunction with DSTG, we've developed a new approach to meet this need, the Human Performance Research Net, known as HIPANET. It's got the potential to change the way in which research partnership is planned and delivered for Army and Land Division, and possibly more widely across DSTG. This scalable model, built on open partnership and mutual investment, will provide a robust mechanism for bringing together and investing in the leading research teams from across Australia to address our needs. At the moment, a total of $4 million in cash funding over 4 years has been allocated to establish and operate the HIPANET. There is the potential for further investment to expand and extend it into the future. We're seeking to establish an enduring partnership with and between members of the HIPANET, and we will be looking for mutual investment in the selected initiatives and a commitment to open engagement. On the 8th of June, DSTG announced the HIPANET and sought expressions of interest for innovative research proposals. Those expressions of interest closed on the 6th of July. We received 65 submissions addressing the full range of questions posed and being provided from universities across Australia. Cross-university discussion and alignment of study proposals that make a systemic case were encouraged. The approach to staffing of each study was not predefined. Based on a potential investment up to $450,000 per study, proposers were asked to detail how these funds would be allocated to deliver their studies' Army-focused outcomes over a 4-year timeframe. They are also expected to demonstrate mutual investment through the allocation of university resources to maximise delivery of outcomes for defence. On average, for every dollar invested by the Commonwealth, universities are prepared to co-invest $1 plus through in-kind and cash, producing, on average, a mutual investment of the HIPNet of around $8 million. A good example of a project using this approach is a current Army and DSTG working prototype of an unpowered exoskeleton that may have potential to mitigate the equipment burden of individual soldiers. It's a sobering fact to realise that some of our soldiers carry individual loads in excess of 60 kilos. This results in reduced physical and cognitive performance through increased fatigue, decreased agility, and increased risk of musculoskeletal injury. I know the performance and sensory collapse associated with being a pack mule all too well. Armies globally have sought a solution to load-sharing technologies such as exoskeletons. However, to date, complexity, power requirements, and energy demands on the user have inhibited military utility and acceptance. DSTG have designed a unique concept technology demonstrator of a simple, unpowered, wearable, flexible exoskeleton that reduces the burden of a soldier's load by over 60% in some circumstances. The OX project, as it is known, is currently at technology readiness level 4, somewhere between the level 1, very risky, and level 9, technologically low risk. The early signs are promising. In a recent test, the wearer commented that the difference between a baseline test, wearing a 20 kilogram load without the exoskeleton, and with it on, was stark. The wearer then elaborated, wearing the OX system, it's hard to say how much it's actually taking, because at the end of the day, you're still balancing the load on top of the cables. This requires the body's core muscles to be constantly active, making the adjustments necessary to stay upright. Taking off the OX system and walking with a full 20 kilograms on my pack, I immediately realised how much I've been taking the system for granted. It's still early days, and no one is claiming that we've solved the problem yet, but I think we can agree that innovation and developmental approaches like this are to be encouraged. Beyond the human performance area, another example is evident in Land Project 129 Phase 4, which seeks to acquire unmanned aircraft systems for the Australian Army to use at the battle group level. The requirement for the first tranche of these UAS is operationally urgent, so the plan is to buy those small aircraft off the shelf. But the second tranche is not so urgent and provides an opportunity to engage with manufacturers who, though they may not be currently undertaking military spec UAS design, development and manufacture, have all of the world-class components to do so. Adopting this kind of approach through initial conversation and the Rapid Prototyping Development and Evaluation seed funding program, we are looking at how we might engage with manufacturers who could quickly come to generate the sort of solutions that we see. I think this would be an extraordinarily positive initiative, and with lots of possibility beyond that first opportunity. I'd also like to acknowledge again both Alex and Kim Gillis for their enthusiasm on taking these kinds of approaches. And it reinforces the point that Army and the other services are reliant on the ongoing collaboration, partnership and excellent support we receive from the other enabling defence groups in order to realise our aspirations. The final point I wish to make in these remarks is that ARMY is also working to reinvigorate the quality of our thinking. Our science, technology and innovation needs are best served when our people are producing insightful thinking that explains and responds to the serious problems confronting us. To that end, ARMY has begun a renewal of its training, education and doctrine under the Ryan Review, a copy of which is available on our website. And I'm establishing an ARMY Research Centre, which will be networked and connected with other thought centres. A science, technology, engineering and mathematics-enabled ARMY needs to be STEM literate and able to guide research informed by concepts of future war. By building rigour of thinking and a culture of learning into our system, we will help inform the future iterations of science and technology innovation we will require in our continuous modernisation path. I encourage you to be part of that journey. Thank you.